breaks up. So I'd like to give a quick introduction to Joe, who's going to be speaking about one of my favorite network tools, Bro. Please welcome Joe.
Hello, everyone. Woo, yes. Hi, my name's Joe. Hi, Joe. No, so the genesis of this talk actually comes from this event last year where John Althouse, who is hanging around here somewhere, gave a really cool talk on Bro. That was my final push to get off my butt and start playing around with Bro more effectively and start seeing what capabilities are out there. So thank you, A Conference on Defense, Art into Science, for generating this in both production and to share some results and work with you. So who am I, other than the guy who's standing up here talking right now? My name's Joe Slowik. I do threat intelligence work for Dragos. Last time I was here, I was running the incident response team at Los Alamos National Lab. Before that, I was an information warfare officer in the U.S. Navy, and prior to that, I was a philosophy grad school dropout. So it's been a circuitous route to get into InfoSec, but it's been a fun time the entire path. So what we're going to talk about today is really this is going to look at Bro as being a facilitator towards doing other things, mainly trying to leverage network visibility to make up for host detection gaps, using that sort of network capture in order to get host-based artifacts that you would really want in order to either initiate an investigation or follow up on one, talk about some use cases and examples, and then, like any other approach, the limitations, because if you don't know what limitations exist and how you're trying to solve a problem, you're setting yourself up for failure, and some compensating actions we can take around that as well. So the challenge, as many things in InfoSec bubble up to the surface, involves Twitter, of course. Malware Jake is Malware Jake, but really the main thing on this one was like, hey, which would you rather have, network visibility or endpoint visibility when it comes to tracking the latest and greatest for APT whatevers? The ideal answer is, well, I really want both, because you're going to need both regardless. But we don't live in a perfect world, so really we need to figure out some way in order to bridge that gap, going back to the title of this talk. So host-based monitoring is very vital, but often less mature, especially in certain environments. Like right now, I work in industrial control system security. You're not putting your latest and greatest EDR, endpoint agent, or whatever on a PLC in an industrial environment. That ain't happening. So you got to figure out some other way of getting around this. Network monitoring, however, is typically easier because it's more centralized. Like you own those boxes, and you can figure out a way to like put a tap-in line or whatever and capture this sort of stuff. So the best answer to try and get to a result that's going to assist us in both monitoring and for responses, try and use one to support the other. And this goes the other way too, of using host to support network, but that's typically not what we're focusing on. So really this will be host to support, or network to support host. So visibility challenges are there regardless of your environment, and they certainly depend upon what you're operating with. So a large Windows domain, yeah, you might have all the tools in place, but you're also swimming in a huge sea of data, and trying to filter down into events of interest is hard. Whereas like an ICS network, like I was talking about earlier, that I'll focus on with some of the examples. Sorry, that's my job now. That's a different problem set in terms of what you have and what sort of challenges you face when attempting to get information out of that. So yeah, there's challenges there, but also opportunities as long as you recognize what the capes and limbs are of what you're looking at and how you can shape that to solve the problems that you have. And that, of course, also involves asking the right questions, which is always the most important thing in security investigations. So, host higher fidelity, ground truth sort of data, but it's difficult to push out and manage. We've, hit on this a bunch of times already, whereas network, easier to implement because it's typically things that you have more control over, but it leaves out some details. But using network to capture host gives you an opportunity, especially when you have a lot of control over how that network traffic and what protocols are in question will play out. So you could look at things like files moving over the wire. Bad guys have to get their stuff on target somehow. It's got to come from somewhere else, and chances are, unless it's magically getting there or it's a USB stick, it's crossing some endpoint or some midpoint that you have visibility on. Additionally, when you're talking about something like remote access tools or other sorts of command and control mechanisms, commands have to get from point A to point B as well. So depending upon how they're flowing from controller to target, you have visibility for this as well. So even if clear text is unavailable, there's still options for trying to at least suss out some details in order to start solving the problem. So one solution is, leverage these dependencies. So if host isn't accessible, again, the same sort of limitations are applying for the attacker. Like, yeah, they might have an implant on there, but it's useless to them unless they can communicate to it in some way or control it in some way, in addition to the fact that they need to actually get that payload on target to begin with. So the key here is that, figure out what sort of traffic you're looking for and some means of analyzing it. So, in terms of dependencies, your adversary is going to need some sort of command and control to an internal compromised host. Well, in order to get from adversary to target, something has to be between point A and point B. So leveraging that, whether that's an internetwork or intranetwork, your edge firewall, or hopefully you've got enough segmentation and monitoring in place that you're catching intra-LAN communication, that then you can do some monitoring and capturing in order to pick these things off as they're moving from here to there. So, Bro. I'm not going to talk to you much about Bro because I'm hoping everyone knows this already, like I said beginning, and I see John joined us or whatever. Thanks, John, for the talk last year. Bro is an open source network traffic analyzer that does awesome things. Enables session level analysis rather than just picking off packets one at a time like a lot of your traditional NID solutions like a Snort or something. It's developed at Lawrence Berkeley National Laboratory, go DOE. Continued development adds functionality, a robust community around this. It's already come up in a couple of talks already for a lot of the functionality you can bolt onto this. But what I'm going to focus on today is a stupid simple aspect of it, file carving. So because you're looking at sessions, rather than collecting packet capture and then pulling out attachments manually, Bro automates file carving from a communication stream. And it applies to various protocols. Pretty much if you can identify it on the wire, it can strip it out. Now, there is a limitation, encryption. We'll get back to this, but to anticipate the question, like, oh, if it's HTTPS, what do you do? It's like, I know, we'll get there. So this is just a really basic example of how to do this, and you can find this at the Bro website. It's a presentation that Bill Stackpole gave a couple of years ago, and this will grab everything, names it, drops it in a directory, like, good to go. Like, it's really not that hard to implement this. The hard thing is like, well, what do you, I have all this data now, what do I do with it? Well, that's the other part. Designing an analytical workflow to take whatever data that you're seeing and then I want to identify the interesting things. So simply carving out files and say, hey, I want a hash, I'm going to check on virus total, that's stupid. I'm sorry, don't do that. Maybe do that, but if you think that's going to solve all your problems, just no, I'm not even going there. But if you're pairing this with an analysis engine of some point, so maybe you're doing a sandbox or whatever, that could be cool. If you can actually, Phoenix Project, it looks like it's awesome as well. There was another great talk this week. But maybe that's not an option either. But even something as simple as YARA, which we'll get into, or detection scripts in order to start flagging and identifying items of interest relative to your environment is not that hard to implement. And again, all of these are open source tools and things that you can do in your basement, let alone applying to your enterprise. So a conceptual flow of how this would work is, capture some traffic, carve out items off the wire, use some initial filter in order to grab things. Like if you're doing this in a Windows domain where internet connectivity is in place and you're carving all files, you're going to get a lot of crap. So really identifying, do I only want PE files? Do I want to look at active content items, stripping things out of HTML but only flagging on those when there's JavaScript involved or something. So some filtering is necessary, otherwise you're going to be in a bad place very soon. But then leverage tools at your disposal in order to identify malicious or suspicious activity to go from there. So the detection possibility I'm going to focus on, along with some supporting mechanisms, is YARA, which, well, I say malware detection, but you could use YARA for anything. It's just yet another regex tool. It's potential for identifying items, like, for example, if you wanted to dig into document metadata or whatever, you could even sort of leverage it for doing things like data loss prevention or catching exfiltration. When I talk about detection scripts, it's really building in these sort of monitoring techniques into something as simple as a bash script so that, hey, I've got a compound file type, let me unpack it, put all the contents into its own separate boxes or whatever, apply relevant scanning techniques to those, and then shoot results off somewhere else. So in terms of YARA, YARA is awesome sauce. I live in YARA, right? YARA for all sorts of things. You see malware analysts use it a lot, but really it's flexible and you can use it for just about anything. We'll cover an example of using it just to look for data of interest in image EXIF data. Now, for an example of what YARA looks like, and that's reasonably large enough that some of you in the front might even be able to read this, just YARA rule for the NotPetya worm, and it bolts a couple of different pieces together. The top one is just using some simple string stuff because that's adapted from a few other things, looking for embedded PSExec within a binary file. That's a useful thing to look for. You don't see that too often. And then below was the shutdown routine that was built into the NotPetya sample that was mercifully reused code from something else and looking for it at a bytecode level. So yeah, you can do lots of things, whether it's identifying functions within the code or just identifying things that you can see in plain text. Now, putting it all together, you get your host relevant artifacts pulled down from Bro. So the same sort of thing that has to flow from attacker to victim, yank that off the wire, sort, process, do whatever in order to distill data into actionable information, and then leverage YARA to produce intelligence. So that classic, intelligence cycle stream or whatever of going from raw, unfiltered stuff down to things that you could actually deal with to the stuff that you really care about. And YARA is an excellent tool in order to start building all that down. So that's a good introductory item for how you piece these sorts of things together. And again, all open source tools that you can leverage for however you see fit. Now, putting it into practice, you need sensors in place, you set up some scripts. We're going to talk about some examples coming up next. What can you actually look for? How does this really apply? I mean, it sounds nice theoretical, but, show me what you've got. So first off, the answer is depends. What are you looking for? What is your environment? If you're just trying to pick off ransomware, it's like, okay, well, that's one item. You probably already have this through, say, an antivirus solution. But what if you're talking about, say, a network enclave like, hey, I've got like this big IBM ZOS monstrosity or whatever sitting in its own network that if someone sneezes on it, like we're not sure if someone set it up in the 70s, we're walking away. Or my own environment, you're talking about a ICS network where you don't have a lot of the possibilities and a lot of things that people just on the IT side don't understand. Well, tailor then to look for the things of interest that you wouldn't be able to carve out otherwise and use that as your proxy for that host-based visibility. Now, example, so crash override malware. Familiarity with crash override and destroyer, so it was used in the 2016 Ukrainian power outage event. It was a fairly flexible malware framework that was deployed to allow for the delivery of modules capable of communicating to the power equipment in question in order to trip breakers and cause a power outage. So it's a purpose-built ICS attack framework. Like, oh, that's, ICS-based malware. There's only, what are we up to, 6 now, I think, total. This was number 5. We're going to talk about number 6 next. But, pretty esoteric malware, pretty difficult stuff to deal with. But when you look at it in terms of what kind of an attack we're talking about, like this isn't just something where fire and forget and walk away. Instead, what you're looking for is, first had to get into the ICS network to deliver your attack payload, establish some sort of foothold and communicate to it, identify where you're operating, and then deliver that final attack payload. Everything prior to delivering that attack payload takes time, effort, and communication in order to pull it off. Well, from a defender's perspective, and especially from a defender's perspective where you have imperfect visibility, there's opportunities in this model. So every one of those little midpoints is a goal to identify staging and pre-positioning as we move down the attack cycle. So looking at the impact module, like, well, I have ADV, like, this will find something. Well, here's the crash override module around the time that it first hit the wild. Yeah, you had a few detections, but, who knows what the hell wisdom eyes is? That could be anything. And another thing, too, in identifying the ICS environment is that you see lots of legitimate software get kind of hokey AV detections, especially on the lower reputation engines. Sorry, Baidu, if anyone works for them, I apologize, but your signature sucks here. This isn't going to help you. But if you look at the actual program itself, from an AV perspective, there's not much. But if you know your environment and what to look for from an ICS perspective, there's a number of red flags in how this is set up that can be honed in on to detect proactively and certainly after you get a sample to pull it apart and identify after the fact. So adding some custom detection midpoint can filter this sort of stuff out, whereas your traditional IT solutions, IT security solutions, aren't going to flag it. So from a specifics standpoint, this was something that was developed tailored to the malware. These YARA signatures are available on the Dragos GitHub as well. So on the first hand, just looking for the configuration file that was used for the IEC 104 module to trip breakers in the target in question. And then, very similar to the NotPetya example I showed earlier, also some things that show up, pretty easy plain text in the string. And this is where things get interesting because these are things that can be looked for sort of proactively, like I see these effects being developed or whatever, and they should only exist or occur within very narrow windows of functionality. So if I see this outside of said windows and I identify this in traffic, like I see this payload moving down, that's something that from an ICS security standpoint, I want to investigate. So, build detections around this. Identify what those, I hate using the word anomalies since that's sort of it's a trigger word for me almost these days, but, identify things that would be malicious, suspicious, or simply out of the ordinary in your environment, and then build those detection methodologies around that. Implement them at those network choke points. So one other theme that I like to talk about a lot is, strategic network defense, trying to segment networks off and create as many possible detection points as you can through segmentation, isolation, and then applying detections at each of those items. We'll talk about that towards the end as well. But, again, emphasizing that malicious code has to be brought into the environment and take advantage of those attacker dependencies to catch them in the act before they get to that final stage of delivering the malicious impact module. So a similar example, talk about TRISIS, also known as Triton, or if you work for DHS, evidently Hatman sounds like a good idea. So this was the third, 6 ICS-focused malware, the third one that actually delivered some sort of impact, Stuxnet, Crash Override, and now TRISIS. This was the first one to target safety systems. So that's bad juju. You don't target safety systems because that's how you get people killed. No one died in this case, as far as I know, but again, safety systems, no bueno. So in this case, establish a backdoor on the targeted safety system in order to allow an attacker to come back and manipulate the logic underlying that machine. So lots of potential to cause process disruption there. Now, the TRISIS attack looked like this. Does that look familiar? Exactly. It's the same thing as crash override. So still have to penetrate the network, establish a foothold, figure out what you're doing, and then deliver that attack. So the same sort of dependencies. This is ICS focused, but again, if you're talking about some, the crown jewels of your environment that are dug deep into the network somewhere, like, your database servers and, customer information or whatnot, presumably, hopefully, there's multiple steps between the open internet and getting there. So flagging on each of those steps along the way, or trying to identify what's going on at each of those steps along the way is vital. So similar challenges in establishing C2. You've got multiple sort of gateways that you have to pass through, and therefore opportunities for us as defenders to monitor that network traffic to see what sort of items will be brought in to deliver a host impact. Now, for the TRISIS defense, the same sort of principles hold. Add detection to your network choke points and look for items of interest traversing them. Leverage that network visibility in order to make up for the complete lack of any sort of host visibility on a safety instrumented system. These are very specialized pieces of equipment that still run, even if you're talking about the engineering workstation that would connect to this normally, that's the system that should have some level of isolation to it. It's going to be a Windows machine, but it's not going to be something that's, you're running your typical EDR or even AV for that matter, because if you have a false AV detection on something that blows away a project file, that's bad because you just lost an awful lot of work and you may have just shut down a process in the bargain as well. Now again, AV, this is not to bash AV, rather an idea of specificity. What are you looking for in your environment? AV is not going to help you here. Why? Well, for one, this was a compiled Python piece of malware that was very specifically tailored to the environment that it's operating in. Quite frankly, AV didn't really have any business looking at this whatsoever, and you didn't see any detections for this until well after this was uploaded to VirusTotal back in August. Now, I caught some flack for using this as an example, like, well, the VT engines, aren't the ones that customers have. Like, no, I don't care. This isn't the problem set that you're typically looking for. And this goes back to the contextuality of defense. Well, what am I looking for? What does look malicious in my environment? So AV failed to pick out TRISIS, but there were a lot of strange items in this binary. For one, compiled Python in an ICS environment, that's just weird and doesn't happen anyway. So that's something to flag on. But additional items in identifying the enumeration and identification of the Schneider Electric safety system, the Triconix device, that stick out. So if you're monitoring for things that look like they're supposed to be legitimate software within the environment, but outside of normal windows, like, oh, I have a detection point within an environment where typically detection and monitoring is very difficult. So looking at the content, file headers, et cetera, for those sorts of characteristics outside of the known good, known maintenance activity immediately identifies items for investigation, and then with some other points that were relevant within the TRISIS malware, make it stand out as malicious. So in this case, at a general detection level, this is something just to look for all things that look suspicious that happen to be compiled Python. So, look for a few flagging items that identify like py2exe, et cetera. But then, because we're talking about contextuality to the environment we're defending, look for the sorts of software that we're trying to look for, including the Trilog safety software. So anytime I see something along these lines coming into my network, that's something I want to investigate because it shouldn't be there. On a more specific level, and this is post hoc, not pre-event, then, all right, I've got some idea of how this attack pattern works, but I also have an idea for how these project files and the ladder logic files should look within the environment. So I've got a different sort of file header, not your PE file header, and then some idea for how these binaries look when they're traveling over the wire. Very specific to the environment, not something that anyone's going to see in an AV engine because, again, it's not really tailored to this, but by knowing the contextuality in the environment, what sort of items you're looking for, because you can flex this out to catch, or to identify all sorts of other similar items, and then carve those items out when you see them in your environment to act as a, tripwire or as a initialization towards a investigation event. So the takeaway here is that you have zero visibility on the endpoints of interest here. They're critical systems, but at the same time, they're systems that don't really lend themselves well to security while they're doing their job in safety. So in order to make up for that, leverage that or that attacker dependency in order to have the same sort of communication issues to identify how they're attempting to interact with it and looking for things that are specific to the environment in question relative to that to identify things that are malicious or suspicious. Last example I'll talk about is a activity group that we track known as Dymaloy. This is sort of a contentious issue because you may have been familiar with how these guys operate from a report Symantec put out, in August or September, calling them Dragonfly 2.0. There's an overlap with the ICS attack group known as Dragonfly, Havoc's malware, but there's significant differentiation there, so new name. Sorry, last thing we need are more names for sort of the same things, but that's how we roll here. But anyway, part of the attack pattern here was screenshotting. Screenshotting, why the hell does that matter? Well, in this case, the adversary was taking screenshots of human-machine interfaces in the ICS environment and using that as an intelligence collection mechanism to map the environment as well as to get idea for how the process control network looked in that situation. So the overall TTPs, tactics, techniques, procedure for operating, so initial access via phishing, some strategic website compromise, your typical sorts of stuff. Deploy some implants, lots of commodity off-the-shelf sort of crimeware things. And then lastly, on an information collection level, there's Mimikatz, because who doesn't use Mimikatz? Framework for harvesting documents, credentials, etc. But then there was that exfiltration of screenshot item that is interesting as well. And there's plenty of detection points around here to look for. A lot of these are captured by traditional security solutions. But this HMI screenshot one, especially again going towards contextuality in the environment you're defending, really sticks out as like, that's weird. I don't know anyone that's really looking at that, but that's really good detection point for us to look for and something that we can key off of, both for this as an adversary behavior going forward. So in this case, the screenshot activity is really a good thing to look for because it shouldn't happen. And when you're seeing that come over the wire, if you don't have the ability to capture whatever tool was used in order to do that natively on the box that's compromised, capturing that on the wire is a good way of telling that something weird's going on. So, catching a PNG or a JPEG or a GIF or GIF, does it matter? Okay. Coming over the wire is not something that you're going to see typically in a security signature. AV doesn't care unless it looks like it's an EXE that's mimicking or attempting to pass itself off as an image file. But in this case, that's something I really care about, and I can leverage this codependency is the wrong word, but this joint working structure of network capture and then a little bit of host style analysis to identify when this is happening in my environment. So simple EXIF. Image size, standard screen resolution. Okay, so one way of going about this is I'm guessing that adversaries aren't going to change screen resolutions for when they're doing this because that's why even bother. Why don't I look for image files that are leaving my target network that match common screen resolutions and flag on those? So in this case, identify that an image file is on the wire coming from, in this case, an ICS network. Carve that file out via Bro and move it to some analysis machine to take that EXIF snapshot and then use YARA to look for that dictionary of screen resolutions. Seems stupid simple. And you know what? It works in this case. So apply YARA to the EXIF results and then pattern off the common screen resolutions and use that as a data alerting point. Again, it's really? That sounds basic, but in this case, it would catch this adversary as they're doing their recon phase of an attack within an industrial control network. That's kind of cool. Now, ultimately, we're really talking about shadows on the wall. So we're only getting part of the picture, and there's limitations to this as there are in any approach. And we're going to spend some time on this because it's important to recognize this and see how we can sort of overcome whatever gaps we have. So it's an approximation. It's not a replacement for host visibility, but it's one way of getting at least some of the way there. So the key weaknesses, I already mentioned encryption. We're going to talk about it. Compound file types, lack of sensors. If you don't have the visibility, this approach doesn't work because you just can't do it. How network topology influences this, as well as the fact that this is reactive and not preventative. So encryption is potentially the greatest issue. Luckily, in my case, encryption doesn't exist as much as you would think within an industrial control network. That doesn't apply for your standard Windows domain. Adversaries are switching to HTTPS. Let's encrypt certificates are everywhere, let alone self-signed, whatever. So encryption is a problem. Like I said, it's not as big of a problem for me, but if you're trying to apply this to a financial services network, you got to worry about it. Well, there are workarounds. SSL intercept, that's always a contentious topic. I would argue from a security standpoint, if you're not doing it, you need to investigate it, but it's a really tough sell. No one likes knowing that their Facebook or email activity as part of their non-work duties and their work computer is being snooped on by the security team, but it's something that we need to try and look at. Another way of looking at this, though, is you could look for host workarounds to make up for that network lack of visibility, which is the complete opposite of the talk that I'm giving right now. Main thing that I'm trying to emphasize is that this is a tough problem, and it's hard to really think of good ways of getting around this, but at the same time, depending upon what sort of issues you're facing, there are workarounds, but where encryption is something you could either bypass because you're doing SSL intercept, or if you have different means of visibility, proxying, or other sorts of items out there, you can figure out a way, but it's something to really be mindful of. Now, going towards more resolvable issues, compound file types. So what I talked about so far works really well for PE files, doesn't work as well for something like the new Office formats, the XML-based things like docx, SLX, zip files, RAR files, etc., because it's a compound file type. There's lots of things that get decompressed and then used in the environment in question. So instead of trying to look at those as a singular object, well, introduce one additional step of complexity and add a processing agent to this as well. So first, identify your file on the wire, carve it from traffic and save it off, then have some initial script to identify the compound MIME type and then extract it and expand it to a temp location and then look at the child files. That seems reasonable, right? Well, actually, it's really stupid simple. So this is just 10 lines of bash? Not even if you take my comments out of this. Just to take XML document types, decompress them, apply YARA and a little grep signature here to look for, grep search here to look for fishery indicators, so IP address embedded within certain sections of the document, and then output results. That's easy. I did this in 10 minutes, something like that or whatever, and it's functionally resilient. So it's doable, it just requires a little bit more effort in knowing what sort of file types you're looking for. It also requires being able to have a place to store these, ship them off, et cetera, and then making sure that you're tuning or applying your detection methodologies for whatever the output of that is. So again, knowing what you're looking for, knowing what you might come across, and then apply lessons learned, good times. Sensor coverage is a more difficult issue to resolve, but it is one that can be resolved. So network edge is typically covered. You're capturing things that are ingressing and egressing out of your network, good story. But to really make this approach powerful, you need that extra layer of detection to catch things like lateral movement, intra-network movement. In the case, a lot of the examples I'm talking about, that IT network to ICS network bridging. So you need to align coverage to catch to these choke points as much as possible and implement sensors pretty much wherever you can. Similarly, topology comes into play here as well. So flat networks in general are bad. If your network looks like a table, that's not cool. But they still exist, and we still have to deal with them. So figuring out some way to either logically or physically segment networks not only is good from a standard security practice standpoint, it also creates those sorts of choke points that you need from a network monitoring perspective, where traffic has to pass through, that you get monitoring attempts to monitor and flag items. So it's an architecture item. It's hard to implement. But once you do it, it's good, and it has many, many benefits to it. Unfortunately, also, if you're doing this in a physical manner, it costs a hell of a lot of money, and your engineers will probably hate you. All right, and lastly, this is a reactive approach. It's a detection methodology. It's not going to stop anything. This isn't like having, a intrusion prevention system or antivirus that'll shoot samples in the face or whatever when they find them. So the damage is already done, and now you're just reacting to it. However, you might be reacting, but you're reacting quicker than before. So, again, I'm sorry to dwell mostly on ICS examples, but one, I think they're cool, and it is my job. The idea here is that you might not have learned of any of these events previously until the lights went out or something broke. Whereas now, at least, you've got a detection point much earlier in that ICS cyber kill chain. Someone please don't throw anything at me. In order to initiate an investigation earlier and hopefully stop something before that attack manifests itself in a physical impact in the environment. Similarly, if you're talking about something like the credit card numbers being lost or whatever, your alerting point isn't seeing massive exfiltration, but ideally it's seeing how the attacker is worming his way into your network, or her way into your network. So picking up in network traffic mean that you can try and identify things before you get a embedding item in poor coverage areas. So enable your defenders to respond sooner. So yeah, talked a lot about ICS. Why? Because one, ICS networks are really well tailored to this approach, and it's my day job. But aspects of this could apply in lots of cases, especially when you have very specific network enclaves that are carved out for very specific purposes, sort of isolated, hard to update, etc. even from a standpoint of looking at a properly segmented network, there's still the possibility of, like, by implementing those choke points along the way, that you're creating defensive points or monitoring points where you can capture traffic and therefore identify the adversary sooner. Ultimately, and I've used this image multiple times because I think it's awesome and it makes me look smart, is you don't want to let the perfect be the enemy of the good. In imperfect situations, you can still improve your security posture. If you don't have endpoint monitoring, which would be awesome, like Sysmon exists, and we had an excellent talk about how to integrate that into Graylog, et cetera. Like, these are awesome ideas and should be implemented where you can, but where you can't, there's still ways of trying to solve these questions of, what executed on host? Am I seeing a PowerShell object coming over the wire? Can I carve out C2 traffic, et cetera? It's not going to work in all cases. This isn't a silver bullet solution, but it gets us closer to bridging some of these gaps where we don't have perfect visibility where we need it, and getting us a little bit closer to being able to respond effectively. It reduces those response times, so if you're talking CISO talk, that time of response to time of remediation, you're decreasing that delta a little bit, identifying things a little sooner than you might have otherwise, and at least just improving matters a little bit. And ultimately, a lot of this approach hinges on something that I like to come back to a lot in talking about defense, is that everyone always emphasizes that, the attacker only has to get it right once, the defender has to get it right every time. Like, it's bullshit. The opposite applies. The defender only has to detect the adversary once, and the adversary has to get it right every time. So even in a general network intrusion event, bad guy has to get in, he's got to gain persistence, he's got to survey that network to figure out where he or she is, what they can do, where they want to be, identify what objective they're going for, deliver the effect payload, whether that's keylogger to, oh my goodness, nation state APT, badware, whatever, and then complete that effect. Every step of this process is a point where we can detect people along the line. And by implementing something like what I talked about here, which is fairly simple to operationalize, at least at a small network, you're then setting up detection points at each stage of this event. So yeah, it's not perfect, but it's one way to increase the number of chances that we get to detect that bad guy and making it easier to kick them out of the network. So with that, I'm done. I hope that was useful. Open for questions. Yes.
Just curious, have you ever had any luck getting further into a PCN other than the edge, like down into the layer 2.5 or layer 2, or level 2.5 or level 2 to try to detect lateral movement once they're inside of an ICS network?
So one thing along those lines, and especially as you're talking about things like software-defined networking and some other logical approaches to introduce segmentation, and this was a good discussion that happened at the S4 event a couple of weeks ago, is instead of just going, and for those who need background, when he's referencing layer 3, layer 2, layer 2.5, the Purdue logical model for ICS network development, segmentation, however you want to phrase it, is that typically you see good segmentation between layers, but not within layers. So one way of doing that, though, is by increasing segmentation and creating those choke points, you then enable yourself to do things like catch that lateral movement or the movement of malicious software, payloads, et cetera, between points. That's one of the items that happened within the TRISIS event between because this was not even like traditional Purdue model, but the safety system network. There wasn't anything between, at least as far as I know from the people who have worked on it and what information I've been able to gather, no network detection between the engineering workstation and the safety controller involved. However, we should do that. And that's where the main issue there is that when you're talking about a plant environment, it's hard to physically do that because you have something that was set up and is going to be there for 10, 15 years, or maybe not that long, but certainly up until your next refresh. So looking for ways where you can logically instantiate those sorts of choke points, or at least detection points, would be key. Have I seen it in too many places? No. Do I advocate for it? Yes. So does that answer?
Yeah,
okay.
It does. I've always wanted to get that far, but no one will let you in that far. So.
Right. And that's where having passive means of monitoring, so like one thing that people look at is like, oh, well, I had an example here for solid AV root and other sort of wormable file infectors. Like, well, that's stupid. AV can take care of that. Like, well, you don't want AV in some of these networks because it'll pick off stuff that you don't want it to pick off, and then all of a sudden you have a bunch of critical executables for companies that don't exist anymore that all of a sudden have been rewritten and are modified in such a way that they're inoperable, and that's a bad day. But being able to try and track things along those lines that you can't automatically, wipe, remediate, et cetera, is critical, because then it gets you at least towards a step of containing that infection event, even if you can't stop it.
I noticed that you mentioned Thank you.
Yep.
I was wondering, just in light of some research in recent years, most notably the security impact of TLS interception or HTTPS interception, I forget the exact title, which advocates very strongly in the other direction. I was wondering if you have tried or have had any success in fingerprinting the actual X509 certificates that are transferred on the wire to see if you can detect the anomalous traffic that way instead of actually inspecting it.
That's an awesome point, and that's something that I've been thinking about very much since yesterday morning. Thanks, John. With the with JA3 or whatever, I wrote it down. But no, so the certificate fingerprinting, yes. In fact, I forgot to bring that up, and I didn't change my slides for it. So one of the workarounds for that, especially because it's a cost-benefit question. Part of me really thinks that no, SSL is good. Let's not break that because it's a security enabling function in most events. But then I put my incident response hat on. It's like, man, it would have been really cool if I could have seen that freaking C2 traffic and it's all encrypted through legitimate encryption mechanisms. But if you can get to a level of at least fingerprinting the traffic in some manner to identify it as malicious, again, leveraging something like Bro to carve certificates off the wire, that's a good approach. So, I mean, the ultimate answer is it depends, which is a crappy answer, but if I think about something like a process network that I'm most interested in, nope, I'm sorry, I'm breaking your encryption. If I'm thinking about something along the lines of a general Windows environment or typical corporate network, okay, that could be dicier, especially because now you're handing over a potentially very valuable data source and mechanism that if that gets compromised or a malicious actor is involved, internal actors involved, you're in a bad place. So yeah, it's a cagey one, but especially with the JA3 capability, it's something that can help get us closer while not actually breaking it, if that makes sense.
Any other questions?
Lunch is next, so I understand.
Lunch. All right. Thank you very much,
All right.
Joe.
Thanks, guys.
We're at lunch until 1 o'clock.